Hi everyone and welcome back to my channel #analytics. For this demonstration, I will be sharing with you on how to deal with Python for data visualization. But before that, I will give you some brief background when we started our data visualization. We started our data visualization by using Excel application. What we did there is we arranged our data, we normalize our table and apply some preset charts available in that application. Then we move into the use of the machine learning tools like Weka, RapidMiner, and what amazing those machine learning tools, it will automatically process your data and you can apply the algorithms to build models to process the new input data. And now we are moving into Python coding, which is also used for data visualization. This is a tool for data science. Why Python? Because it is a free open source where you can access that in this website, anaconda.org website. And what is the good thing of this Python? Python is so simple. And if you are into coding, you can easily adapt the syntax. It supports the functional, procedural, and both object-oriented programming and aspect-oriented programming. So the objective of this demonstration is to provide you an introductory guide on how to deal with Python for data visualization. And we will start that by generating the charts from our sample data sets. For that purpose, we will apply some libraries like pandas that allows us to manipulate data from its rows and its columns. Then we will apply the NumPy library that allows us to make some numerical analysis of our data sets. And we also apply some the matplotlib module that allows us to create some two-dimensional graphs of array, and we apply the pyplot functions which allows us to create some figures and do some labels of our graphs. And now let's start working with our Python. So we are in this environment, Jupyter Notebook. First thing to do is just click on the new, then select the Python 3, then you are directed to this working environment of Jupyter Notebook where you can write and execute your code. Okay, to start with, we will be importing our pandas library and we will assign a variable PD for that. Then the use of this panda is for us to manipulate our tabular data. Okay, then run. Then we also apply the module matplotlib. Then we are also using the function of the pyplot for us to create figures and make a decorative style of our graph. So this will allow you to create a two-dimensional chart. Then run. Then we are going to read our CSV format, so making sure that you have save your CSV Excel sheets or your data sets in your Python folder. Okay, then let's go back and let's read this CSV file. So we assign a variable DB for that. Then we will read that since PD is for us to manipulate our data sets. Then we read the CSV underscore CSV. Then inside the parameter is the name of our CSV file, .csv. Okay, then we run it. So for us to check the contents of our CSV file, since we store that CSV file into DB variable, so you have to type DB, then run. Then there we have it. So we have a 267 rows here, and we have here the indices. and all the attributes are displayed here. Then next is if we're going to know what is the type of your data sets, all you have to do is to type the keyword type, then the variable that you assign for your CSV file, then run. And this is what we call, this part is our data frame. Okay, that's pandas name for our data sets. That's data frame. Then if we're going to access the value, so as you can see, we have here the NAN, so there's no value on this. If we check our data sets, I have here the lines here. Okay, so I have here the blank one, so that's the reason why, because I computed the mean, okay, here. So that's the reason why we have this, okay. And next is we're going to access the column, and we use the scientific ability attributes by typing the DP, then scientific ability. So take note on how do you write your code here in Python in your input cells here. Is this the same with your attributes name in your Excel application? So there's no space, so therefore there is no space in here, so that you can avoid some errors. Then run, then there you have it. And if you want to know what type is it, then type then db that scientific ability, then run. So this is a series, so the columns, so the first series, and the entire data sets is our data frame. Then if we're going to locate some values of your data sets, in particular this attribute scientific ability, so all you have to do is to type db then scientific ability, then dot access, then indices location, then the square bracket is the number of indices, for example 1. So when we run this one, so it will generate 71. So let's check if that is 71. It's 71. So if you have noticed, the value here are represented in a float, because Python default is float. If you want to convert this into integers, so you have to make some conversion. And now let's move on to the generation of our chart. So since the variable that we use is plt for the generation of the chart, then we have to type it here, plt, then the plot function. The plot function inside the parameter is we're going to compare the English values or the English performance of the students and the scientific ability. Okay, let's check our data sets here. We have the scientific and the English. Okay, data sets. Let's go back. Then let's try to generate. So let's run this one, and there we have it. So it will generate our two-dimensional graph. So this is the x-axis and the y-axis. This will represent your English, and this is the scientific ability. And if you're going to add more attributes to this, all you have to do, just copy, then do some, okay, and include some attributes db that, of course, still English is our x-axis. Then we have our reading comprehension attributes. Then we run it. Okay, let's check. So we have already another line graph, and that is color orange, and we have the blue one. So that's our scientific ability. Now you're going to modify this graph by incorporating an argument. Okay, so we are going to incorporate an argument to modify our graph um, into a dotted format. Okay, let's O, then O, as an argument. If you're going to modify our graph, then let's make a function show here. Then let's run this one. So this is how it looks like. Okay, then if we're going to put some legend and title of this graph, all you have to do is just copy. Then do have to type legend, then the square bracket, and the scientific ability. You can have here the space and comma, since this is only a legend, so it will not affect your code. Reading comprehension, so and shun. So as you can see, there's no space here and there's a space here because it's only a legend. Then you can also put some title on it. Okay, some title. Let's say this is your academic performance. In Python, you can use single quote or double quote. Then PLT, you can put some X label of your graph. Say this is English performance. Okay, now let's check. Okay, run. So this is how it looks like. So we have already the title, we have already the legend, and we have already the label. Okay, now let's create another graph. We have to create a bar graph, but for bar graph we're only using a single attributes. So for that purpose, for that reason, we have to make some positional argument. And since we are dealing with arrays, so we have to apply this library, the NumPy, as NP. So then we have to uh, incorporate this matplotlib for us to generate the graph and run it. Then we have to make the position of, let's say we have to create a variable y position is equal to our np is our variable for our numpy to work with arrays, and that array range. Then we have also to declare our length of the array, that's len. Then our scientific attributes. Okay, let's display, then let's generate the array for this one. Okay, then run. So this is how it looks like. So this is the array of our scientific ability. Then after that we have to create our graph. So plt bar, then we have to apply our variable y position, then db that scientific ability, then let's run it. Okay, so this is how it looks like. If you want to add some attributes, you can add. Okay, then plt.bar, so we have another attribute, db, that's comma, y position, sorry, comma, then reading comprehension, there's no space because in our Excel application there's no space. plt bar, that's a bar function, and inside the bar function is our parameter db that verbal ability. Okay, then let's have to have a function show, and you can now incorporate here your legend. Okay, legend, so it depends upon you what legend, or the y-axis, on y label. Okay, let's say y label on it, because we have on the y label, this is your NCHI results. Okay, then your title, performance, no, academic performance. performance. Then let's run this one. We have a problem because the red that's mistakenly right the okay comprehensive, that's comprehension. Okay, sorry. Process copy, then um, it's comprehension, that's not comprehension, and then run. There we have it. So we have our bar graph. Okay, this is how you did your Python code by generating a graph. So before I end, I will explain to you the code part by one. So we have here our libraries pandas that allows us to manipulate the tabular data in rows and in columns. So we represent that as PD. Then we have our modules matplotlib live, and we have to use our function pyplat for us to generate the two-dimensional chart, and we have this variable for this functions. And we have, of course, to read our CSV file, and we store that in a DB variable. Then we display what's inside in our DB variable, and we have to know what is the type of our DB variable. Then that's the data frame, and if you want to know the specific column, that is a series by typing type keyword, and that is a series. And if you want to access the value of your attributes in a specific index, then this is the code that you're going to use or to type. Then for us to generate the plot, of course, we will be using the variable plt and the function plot. Then inside the parameter is this is a comparative values between the English and the scientific ability score. Then if you want to add some attributes here, then all you have to do is just add. Then it will generate you the graph. Okay, we have two line graphs here. And if you want to make some modification and change the style of your graph into a dotted one, then all you have to do is to include some argument, that's O, and this is how it looks like. Then if you put some labels, since we have incorporated the pyplat function, then you can do some legend, title, and the label of your graph. And for the bar graph, since we are dealing with only with one column, so you cannot pattern this code in creating or generating the bar graph. All you have to do is to import your numpy as np. Then we have here the percentage matplotlib inline for us to generate the two dimension or the array that we have and create a bar graph. Then we have to make a position. So this is a variable, the y position, and we have the np and array range length, then our scientific ability attributes. Then we display our array for the scientific ability attributes, and this is how it looks like. Then that variable will be used in the generation of the graph. So we have the PLT and the var functions. So inside the parameter is the position of our values of the scientific ability attributes. Then this is now the your graph or your bar graph. And if you can add some more, so there's an error here because I mistakenly typed the word comprehension. It must comprehension. It must be comprehension, not comprehensive. And this is the correct one. Okay, this is how it looks like. Okay, this is the generation of graphs. This is just an introductory. I hope that you learned this demonstration, and thank you for watching my analytics channel.